All right, welcome back to another episode of Math with Mr. Young. So today's lesson, we're going to work with 5.1 algebraic expressions. Our standard is 6th grade evaluating expressions A, and our objective is that by the end of this lesson, we're going to be able to evaluate algebraic expressions given values of their variables. In our mathematical literacy, we have algebraic expression, variable, term, coefficient, and constant. All right, so for today, we're going to work on 5.1 algebraic expressions. Our success criteria is that we're going to be able to identify parts of an algebraic expression. We're also going to be able to evaluate algebraic expressions with one or more variables and evaluate algebraic expressions with one or two more operations. All right, so let's go and attack the mathematical literacy, and by that I mean vocabulary words. So an algebraic expression, it is a mathematical phrase that contains numbers, variables, and variables are letters or symbols used in place of a quantity that we don't know. In other words, we have a missing number. All we do is just place a variable there that represents a missing number, and you could use any alphabet or letter, A through Z. And then we also have operators. Operators are multiplication, division, addition, and subtraction. All right, so what I'm going to do next is I'm going to go ahead and write an algebraic expression. Now, an expression, remember that an expression does not have an equal sign. So here we have a math sentence. This is a math sentence, 6x plus 4. Now, again, this is an algebraic expression. So this is an algebraic expression that we're showing you right here as an example. So, just so we know, this letter here, we have the letter X. That is what we call a variable. And again, a variable is a letter, or it could be a symbol that we use in place of a value or quantity that we don't know. So in other words, we don't know what this value is, so we just put in an alphabet. In this case, we put the alphabet X there. Now, to the left of that variable, you have 6. So 6 here would be called a coefficient. Okay. Now, a coefficient, just so we know, a coefficient is basically a number that is attached to a variable. Okay. So like this case, 6x. So what we do when we have 6x is that we multiply the number times the variable. Any number that is used to multiply a variable, in this case 6, is called the coefficient. Okay. Now with that being said, in green, we call this a term. Okay, so this is a term. 6x is a term. All right. In terms, and in expression, a term is made up of one or more terms. So in this case, a number by itself, or the product of a number and a variable, sometimes there's more than one variable. Each term is separated by an addition or a subtraction sign. In this case, we have an addition sign. So we have one term here. So 6x is a term. The coefficient 6, the variable x, we have the term 6x. There is another term. Remember that terms are separated by addition or subtraction signs. So in this case, we have two terms. 6x is one term. The other term is 4, and it's separated by the addition symbol. Now, the number that is by itself, a number that is just by itself, this is called a constant. Okay, so we're talking about the anatomy about an algebraic expression here. Now, a constant is a number that stays fixed in an expression. It stays constant, meaning that it doesn't change. So for an example, we have the expression 6x plus 4, and the constant is 4. Okay. So again, here's the anatomy. There's two terms separated by either an addition sign or a subtraction sign. In one term, we have 6x. The missing value is x, so that's our variable. The number by any variable is called a coefficient. and then again the constant is going to be 4. All right, so let's say for an example, let's say that we're given the value that x equals 2. So if x equals 2, then I'm just going to bring this down. Then we would substitute 2 for x, or x for 2. Okay, and rewrite that. And again, using the gamma, or the order of operations, you multiply first. 6 times 2 is 12, plus 4 is going to be 16. Okay, that is if x equals 2. All right, again, whenever you have a coefficient with a variable, the operation that you do there is always going to be multiplication. So just to recap, an algebraic expression is a mathematical phrase that contains numbers, variables, and operators such as multiplication, division, addition, subtraction. And the anatomy of this algebraic expression, 6x plus 4, there are two terms. One of the terms is 6x. 6 is the coefficient because it's right by the variable x, the unknown value. And the two terms are separated by the addition symbol, and your constant is going to be 4. All right, let's go ahead and move on. All right, so part 2 of your mathematical literacy, mathematical vocabulary. We have 3 categories. We have operation, operator, and keywords. So for the operation, we have sum. And the operator symbol for sum, when we add, remember that sum means to find the answer to an addition problem. Keywords that tell us to add are greater than, added to, more than, plus, increase by. They all mean to add, to find the sum. When we're asked to find the difference, the answer to a subtraction problem, there's your operator symbol for subtraction. You have keywords here: less than, subtracted from, increased by, and fewer. These all mean that you have to find a difference. They all mean that you have to subtract. All right. And now for the operation of finding the product, remember that the product is the answer to a multiplication problem. This one has a few different operator symbols. You have an X, you have a parentheses, and you have a dot in the middle of your two factors. Okay, these all tell you to find the product, the answer to a multiplication problem. Keywords here that tell you to multiply are times, multiplied by, and the word of tells you to multiply to find the product. Now lastly, the quotient. The operator symbols for quotient, the traditional one would be the division symbol, but reality is that this is like a fraction bar here. Here's your numerator, your denominator. You have no values in there, so it's like a fraction. But ultimately, that just means that this symbol here, the division symbol, is really a fraction bar and a numerator and denominator. Okay. You also have that box here that you can use. Now these operators, again, tell you to find the quotient, the answer to a division problem. Keywords here that tell you to divide are divided by and the word per. Again, they all tell you to find the quotient, the answer to a division problem. So once again, you have 4 different operations: addition, subtraction, multiplication, and division. The operator symbols are here, and your keywords are over here. So make sure that you know this stuff, and make sure you put this in your notes. All right, so for the first examples, all we're going to do is identify the parts of an algebraic expression. So identify the term, the coefficients, and the constants in each expression. So we have 2 expressions here. The first expression, you have 5x plus 13. The second expression, you have 2z squared plus y plus 3. All right. So here again with A and B, these 2 different algebraic expressions, it didn't tell you to evaluate. It just told you to find and identify the term, the coefficients, and the constants. So let me color code this. So I'll use blue, I will use red, I will use orange. So the term will be in orange, the coefficients in red, and the constants in blue. All right, so let's find the terms. Now remember, the terms are separated by an addition symbol or a subtraction symbol. So if you look at 5x plus 13, the 5x and 13 are separated by the addition symbol. So 5x is a term and 13 is a term. So these, my friends, are called terms, separated by the addition symbol. On the other side, so there are two terms, by the way, but on the other side you have 2z squared plus y plus 3. Again, the addition symbols separate the terms. So 2z squared is one term, y is another term, and 3 is the third term. So these guys are the terms, and for this algebraic expression there are 3 terms. Alright, so we found the terms for each expression. Next, we want to identify, let me just throw in here variables. We'll take it a step further. We're going to find variables in purple. Now, look for letters, look for alphabets. So if you see here in the term 5x, you have the variable x. On the other side, z squared, this would be a variable, and also y would also be another variable. Okay, a letter, an alphabet that represents an unknown value. Okay, next, by every variable, the number right by every variable is called a coefficient. Okay, so in red, 5 would be a coefficient in 5x, the term 5x. 5 would be a coefficient. On the other side, 2 would be a coefficient because it's by 2z. Also, there's also a 1. If you have a variable just by itself, there's always a 1 there. So technically 1 would also be a coefficient. Okay? Oops. And the last thing that we're going to look for are constants. Now constants I circled in blue. Constants are also a term, but it doesn't have a coefficient because there's no variables. It's just a number by itself. Okay? So in this case, the term 13, again separated by the addition symbol, this would be a constant. Same thing on the other side. You have 3 that's by itself, and this is also a constant. All right, so take a good look at that. One more time just to recap. The algebraic expression 5x plus 13, there are 2 terms, 5x and 13, separated by the addition symbol. You have the variable x, which is an alphabet that represents an unknown value, and the number right by the variable is called a coefficient. So 5 is a coefficient in 5x. And 13, a number by itself, it's also a term by itself. A number that's a term by itself is a constant. Okay. On the other algebraic expression, 2z squared plus y plus 3, you have 1, 2, 3 terms separated by the addition symbols. The alphabets or the variables for the unknown value is z squared and y. So you have 2 variables. Your coefficients, the numbers right by the variables, is 2. Okay, so 2 by 2z squared, and 1 right by the y. There's always a 1 there, by the way. And then lastly, your constant is 3, another term that's by itself separated by the addition symbol, so your constant is 3. Alright, so for this next problem, we're going to write algebraic expressions using exponents. So our directions tell us to write each expression using exponents. And this is pretty easy, just pay attention. Alright, so we have A, B, C, and D. Now with each of these expressions, using exponents, check this out. What alphabet do you see for the A? Well, you see the letter D. How many I guess, how many do you see? Let's count. 1, 2, 3, 4. So that would be to the fourth power. Again, here's your base number. Okay, and then your exponent. All right, it's pretty simple. Then you just do the rest like that. So let's look at B. So B, we have 1 5/10 times h times h times h. So your coefficient, the number is always going to be on the left side of the variable h. How many h's do you see? 1, 2, 3. So the expression will be 1 5/10 h to the third power. All right, there you go. And that's it. Again, h to the third power. The 3, there's your exponent. Your base number or your term, I guess your base number is going to be 15h, right? So there you go. Actually, your base number is h. Just h. Okay, the variable h is your base number. Now again, don't forget that between your coefficient and your variable, the operation you do is multiplication. All right, so let's look at C. Now what letter or alphabet do you see? You see the alphabet J. How many do you see? Let's count them all. So you have J times J times J times J times J times J. So let's count. You have 1, 2, 3, 4, 5, 6. So that would be J to the 6th power. Again, your base number is J. Your exponent is 6 because there are 6 exponents. What am I saying? There are 6 J's. So your exponent is 6. And then lastly, for the fourth problem, you have 9 times k times k times k times k times k. Now you always write the you always write the number first. So the number you see there's 9. Then you have your base number k. And then how many k's do you see? There's 1, 2, 3, 4, 5. So the expression is going to be 9k to the 5th power. Again, your base number is k, your exponent is 5. Okay, between these guys you multiply 9 times k. All right, there you go. All right, for the next example, we're going to evaluate algebraic expressions. So remember, anytime you see the word evaluate in math simply means to solve. So we're going to evaluate the expression k plus 10 when k equals 25. So check this out. This is so simple. So you have k plus 10, and it even tells you the value of the variable. So k equals 25. So you have to substitute 25 for k. Now what's 25 plus 10? 35 is your answer in the algebraic expression. There you go. That was so simple. All right. Now let's look at B. We're going to evaluate the algebraic expression 4 times n when n equals 12. So again, 4 times n when n equals 12. You could even set it up like this, 4n. Just like a term, like you have a coefficient and a variable. So we're going to put 12 for n. So 12 here. Now what's 4 times 12? Well, if you count in multiples of 12, there's 12, 24, 36, 48. So 48 is going to be the product. Okay, product because we multiplied. And this one for A, 35 is the sum because we added. All right. Now down here for C, we're going to evaluate 24 plus C when C equals 9. So again, we're looking for the sum because we're adding. So we have 24 plus C. Now when C equals 9, we have to substitute 9 for C. So here's C, substitute 9. Now what's 24 plus 9? Well, 24 plus 9 is going to be 33. And there you go. 33 is the sum. All right, we're going to continue evaluating an expression, this time with 2 variables. Last time we we evaluated the algebraic expression with one variable, but this time we have two variables, okay? So we're going to evaluate n minus m. So n minus m when m equals 12 and n equals 30. So let's say n here equals 30 minus m, which equals 12. So in reality, all you're going to do is just subtract. 30 take away 12 is going to be 18. So the difference is 18. Now I say the word difference because we subtracted. All right. For b, we're going to evaluate a divided by b when a equals 16 and b equals 2/3. So a here equals 16 divided by b, which is 2/3. Now again, we're going to divide a whole number by a fraction, and we went over that last time in chapter 2. Okay, so all you do here is turn your whole number into a fraction by putting a 1 underneath of it. You're going to rewrite it 16 over 1 times 3 over 2, and you're going to multiply fractions now. 16 times 3 and 1 times 2. Now you're going to multiply your numerators. 16 times 3 is going to be 48 divided by 1 times 2, which is going to be 2, and half of 48, okay, 48 divided by 2 is going to be 24. So your answer, or the product, is going to be 24. All right. And lastly, for C, we're going to evaluate the expressions when P equals 24 and Q equals 8. So P divided by Q here, P equals 24 divided by Q equals 8. So 24 divided by 8, you can count in multiples of 8 if you want to. 8, 16, 24. So that's going to be 3. All right, pretty simple. If you want proof, 24 divided by 8, 8 can go into 24 3 times. 8 times 3 is 24. 24 take away 24 is 0. The quotient is 3. And for the next expression, you have Q plus P. And again, P equals 24 and Q equals 8. So Q equals 8, substitute, and P equals 24. All right. So 24 plus 8 is all you're going to do. Now 24 plus 8 is going to be 32. The sum equals 32. I say sum because we added. All right. Well, there you go. And lastly, we're going to work on evaluating expressions with two operations. Operations meaning multiplication, division, subtraction, or addition. Okay, so again, it's the same thing. Evaluate, one more time. The word evaluate means to solve. Okay, we have to substitute known values for the variable. So in this case, you have the algebraic expression 3x minus 14. So you have two terms. 3x is one term separated by the subtraction symbol. 14 is another term. You have one variable, that's x, the unknown value, and you have a coefficient. The number right by a variable is 3. So coefficient 3, variable x, and then your constant is 14. Okay. So all you're going to do, if x equals 5, you're going to substitute 5 for x. So in the expression 3x minus 14, you're going to put 5 for x minus, there you go. So then Gamma, or the order of operations, you multiply before you subtract. So 3 times 5 is 15 minus 14, you're going to have 1 left. Again, with two operations, we multiplied and subtracted. All right, so there you go. That's really it. Now let's look at B. Again, we're going to solve, we're going to evaluate. So we have n squared plus 8 and 5/10 when n equals 2. So if you substitute 2 for n, this is going to be 2 squared plus 8 fifths, or what am I saying? 8 and 5/10. Now 2 squared is not 2 times 2. Well, in this case it is. But 2 squared really means multiply the base number to itself twice. 2 times 2 is 4. So this will be 4 plus 8 and 5/10. Now 8 and 5/10 plus 4 is going to be 12 and 5/10. There you go. Again, we evaluated expressions with two operations. So for this one, we again multiplied and added. All right. And lastly, we have to evaluate the expression, excuse my dog again, 5y plus 1 and 30 minus 24 divided by y. I have two expressions down here just to give us some extra work. But y equals 6. Again, we're going to substitute 6 for y. So 5y. So we're going to put 6 here for y. Put parentheses around it. Okay, there you go. We're going to rewrite that. So the expression 5y plus 1, you have two terms separated by the addition symbol. 5y is one term. 1 is one term. 5y, y is your variable, 5 is your coefficient, and 1 is your constant. Now 5 times 6 is going to be 30, plus 1 is going to be 31. Boom. Again, you use two operations. We multiplied and added here. Last one here. Now again, y equals 6, so you substitute 6 for y. Rewrite the expression. Now, according to the order of operations, you are going to follow GEMMA. And GEMMA is the grouping symbols, the exponents, the multiplicative operations, and then your additive operations. So GEMMA. Grouping symbols, exponents, multiplicative operations, and then your additive operations. Okay, so all you're going to do now is follow that. So in this case, you're going to look at subtraction and division. So which one are you going to do? Well, you're going to divide first according to the order of operations. So 24 divided by 6 is going to be 4. Okay, and then bring down everything else. Now 30 take away 4 is going to be 26. All right, there you go. I hope you had a lot of fun as much as I enjoy teaching this, and I'm really excited about this lesson dealing with algebraic expressions. So by now, according to our success criteria, you should be able to identify the parts of an algebraic expression. You should also be able to evaluate algebraic expressions with one or more variables, and you should now evaluate algebraic expressions with one or more operations. All right, so make sure you guys pay attention in class, and let's have some more fun, and we'll see you guys in a bit.